Welcome once again to GER Hub. In today's video, we shall be discussing fast shortcut rules to finding LCM of numbers. If you haven't subscribed to the channel, please smash a like on the video and subscribe to the channel by clicking the subscription button below and endeavor to turn on your notification bell, as it will enable you get notified when we drop a new video or when we go live. Now, to understand the concept of LCM, you need to understand the concept of factors. So the question begins here. What are factors? Factors are numbers that can divide other numbers without leaving a remainder. So 5 and 2 are factors of 10 because 5 can divide 10 without leaving a remainder, and in that case you would have your result as 2. So when 5 divides 10, the result is 2, no remainder, and when 2 divides 10, the result is 5, no remainder. So 5 and 2 are factors of 10 because they can both divide 10 without leaving a remainder. Similarly, 4 and 5 are factors of 20, and 7 and 2 are factors of 14 because they can divide 20 and 14 respectively without leaving any remainder. So what again are factors? Factors are numbers that can divide other numbers without leaving a remainder, and it is very important you understand factors to understand LCM of numbers. That being said, let us now go into answering the question, what is the LCM of two numbers? So the LCM of a number, or the LCM of two numbers or more, refers to the least common multiple of these numbers or the lowest common multiple of these numbers. Simply put, the LCM of two numbers, say x and y, is the smallest number z for which x and y are factors. So once presented two numbers or more, the LCM of those two numbers or more will be the smallest number for which x and y or more numbers are factors, okay? And it is very important you note this. So what shortcut rules are available for finding the LCM of numbers? Most times people compute the LCM of numbers taking it to be something very difficult. This video comes to address that issue. It helps you to know shortcut rules that will help you get the LCM of numbers without stress. So rule number 1, the LCM of two numbers that are not factors of one another is the product of the two numbers. So if I give you two numbers, say 5 and 7, the LCM will be 35, simply because 5 is not a factor of 7 and 7 is not a factor of 5. So once presented two numbers that are not factors of one another, the LCM is the product of those two numbers. Of course, 3 and 4 will have the LCM 12, and 2 and 7 will have the LCM 14, because 3 and 4 are not factors of one another, so the LCM will be the product of the two. Similarly, 2 and 7 are not factors of one another, so the LCM will be the product of 2 and 7, which gives 14. You can quickly see this particular question, the LCM of 4 and 9 will be 36, because 36 is the product of 4 and 4 and 9 are not factors of one another. So the LCM of two numbers that are not factors of one another will give you the product of the two numbers. Hold on to this rule, it will help you in getting the LCM of numbers. Rule number 2, the LCM of two numbers having one as a factor of the other is the greater number. So if I present to you two numbers with one of them being the factor of the other number, then the LCM will be the greater number or the larger number. So if I present to you 5 and 10, the LCM would be 10. You don't have to think about it because 5 is a factor of 10 and 10 is the larger number. The LCM of 4 and 16 will be 16 without you thinking about it or calculating anything, because 16 is the greater number out of 4 and 5. And 4 is a factor of 16. The LCM of 6 and 36 will give you 36 because 6 is a factor of 36 and 36 is the greater number out of the two. The LCM of 3 and 27, you can guess, will give you 27 because 3 is a factor of 27. You can divide 27 without leaving a remainder, and 27 is the greater number out of the two. And that is rule number 2. So once presented two numbers such that one of them is a factor of the other number and the other number is a greater number, then the LCM will certainly be the greater number, so you don't have to compute anything or think about it too much. Now let's go to rule number 3. The LCM of two numbers that have a highest common factor is the product of the highest common factor, HCF, and their quotients, okay? So if I present to you two numbers, say 4 and 6. Notice that 4 is perfectly not a factor of 6 and 6 is not a factor of 4, but they have a highest common factor common to two of them. So what is that highest common factor? It is 2. 2 can divide 4. It is the largest number that can divide 4, and it can also divide 6 without leaving a remainder. So 4 and 6 have their highest common factor to be 2. Now, once given 4 and 6 to find the LCM, all you have to do is to bring out that number which is the highest common factor, in this case 2, and when 2 divides 4, you will have a quotient 2. When 2 divides 6, you will have a quotient 3. So the LCM will be 2, the common factor, and 2 for the remainder, or the quotient of 4, and 3, the quotient when 2 divides 6. So the LCM of 4 and 6 will be 2 times 2 times 3, giving you 12. Similarly, the LCM of 6 and 16 will be 48. Why is that so? 16 and 6 have a highest common factor 2. So bring out the highest common factor 2. You'll be left with 3 and 8. So when you multiply 2, 3, and 8, the result gives you 48. Similarly, 9 and 15 have an LCM 45, simply because the highest common factor is 3. So bring it out. When 3 comes out, you are left with 3 and 5 respectively from 9 and 15. And the LCM will be the product of 3, the highest common factor, with 3 and 5, giving you 45. So you can quickly see that the LCM of 10 and 25 will be the highest common factor multiplying the quotients after dividing by the highest common factor. So when you bring out the highest common factor, which is 5, you'll be left with 2 and 5 respectively from 10 and 25. So the result will give you 5 times 2 times 5, which gives you 50. So it is that easy to find the LCM of numbers following these rules. Thank you very much, and thank you for watching.